Hello everyone. Today we'll talk about the solution to the problem, find the number of distinct colors among the balls. This is a pretty standard problem where we're going to essentially be simulating the process, and we have to make sure that we can perform every step of the simulation in constant time. To do so, we have to remember the current number of distinct colors that we have. We also have to, of course, be able to update that number of distinct colors. And to do so, we'll first of all need to keep in mind the colors of the balls that we currently have, because by performing the next step in our query, we'll be recoloring a ball, and maybe that ball was the last ball of its color, so you have to remember its old color, so you have to remember those colors somehow. And also to make sure that we can easily calculate the number of different colors that are represented, we have to remember the number of balls for every color, because we have to be able to answer a question. Okay, I'm recoloring this ball from color A to color B, and is that ball the last ball of color A? If it's the last ball, we lose one color. Otherwise, we don't lose the color. And did we have a ball of color B? If not, then suddenly we have a new color. Color B is now represented by that single ball. So we have to remember the number of balls for every color. And both of those things, both the color of every ball and the number of balls per color, can be kept as dictionaries, so essentially as hash maps. So we can here have a dict, and here we have a counter. Counter is essentially a wrapper over a default dict of integers, and a default dict is a dict that if an element doesn't exist within it, it just creates it with a default value. For the default dict of int, it'll be a 0. So essentially dict is the most primitive form, where if the element doesn't exist and we try to access it, then we get an exception that that element didn't exist. And you'll see how we'll both use the dictionary and the counter. Here cur is the number of distinct colors that we have, and res will be essentially remembering all the values of cur for every query. Now, in our query, we have a ball and a color. So, if that ball, it has already been colored, we just check if it's in ball color, so in this dictionary. We have to take its old color and mark that this is now one fewer ball of that color, so in this balls per color we subtract 1. And if now that value is equal to 0, we subtract 1 from cur, because we have lost the last ball of the color of the old color of our current ball. And now we color that ball to this new color. We get a new ball of that color, and if that is the first ball of that color, so after this addition we have exactly one ball, that means that this is a new color, so we have to add 1 to the current counter. So these two things are symmetrical, and in particular, if we try to recolor a ball from color A back to color A, then we'll subtract 1, maybe update the result, add 1, maybe update the result, but everything is correct. We remember the current result, and of course at the end all those current results that were remembered in this list are returned. So very standard simulation problem where the hash map is doing most of the heavy lifting. And of course the fact that we can maintain the answer in an integer variable and update it quickly by remembering the number of balls per color is an observation that's useful in solving this problem.